Okay, so we're going to start with the one that says paired T interval notes. So we have a lot to get through, but
it's going to be great.
confidence interval. And we see we have two sets of data. You have to think back to what we did on block day where we had to identify, is this independent or is it paired? Okay. So one of the things that you can look at is you can see, is it quantitative data? Is it measurements? Okay. Are these measures of something? Are we doing how many questions scored correctly? The heights of people, the weights, how fast they were driving. Quantitative values. Does it make sense to find a mean? Okay. If it is not, then it's going to be proportions. We don't have a paired test for proportions, so it would not be paired. If it's quantitative and we can find a mean, then we want to look to see, is it paired? So we know we're doing a t-test because it's quantitative. We're dealing with means. Then you have to say, is there a reason to pair them up, or are they independent? If they are paired, then that's where you're going to do what we're doing today. So don't wait until you get to the very end and you're writing a conclusion and go, oh my goodness, this wasn't even paired. And now you've done everything before you realize that. So check that at the beginning. Make sure you're picking the right test, and then you can go from there. So if we're doing a confidence interval, this is going to be called a paired T interval. And since we're dealing with means, we're going to be defining what that is. So mu, and then whatever your subscripts that you use, 1 minus 2, or however you wrote that, is the true mean of the differences in whatever our context is. Okay? So in movie prices between these two movie theaters, or between whatever it is that we're looking at. And our degrees of freedom is n minus 1. So it's the number in each sample, which should be the same because they're pairing them up, so you should have the same in each sample, or how many differences you had. So when you pair them up and you find the difference for each pair, you're looking at how many differences minus 1. And you'll see that as we get into it. So for our next part, we're going to look at conditions. Our conditions are exactly what they were for the 2 sample or the 1 sample test. So any of our t-tests, same conditions. So the first one was good quality data. And we check that by seeing, was it randomized? So we want either randomly selected, or randomly assigned. So we want something to show randomization. That gives us good quality data. What was our second condition? Normality. Very good. And we have 3 different ways we can check for normality. Okay, so we have, it could be that the sample size is greater than or equal to 30, then the CLT applies. That's one way we can meet it. Another way, it could be that it's just stated that it's normal. And then the third one, and this one is the one we're going to be using on today's example, is if the data is given. So then we'll graph it. And when I say graph it doesn't just mean graph it on your calculator and then describe what you see. You need to sketch the graph on your paper and describe what you see. So you need to be able to see what the graph looks like on your paper. And then we're going to check for skewness and outliers. And that would be if you're doing like a histogram or you're doing a box plot or you're doing something like that to graph the data. That's what you would do. If you're doing a normality plot, you're going to check for linear. Okay? So we're going to check our data. And then the last condition, this is going to be one that we didn't have before, but now you will. We're going to check for, is it dependent or paired? So this is what we were doing yesterday. Is it paired or is it independent? So dependent, paired mean the same thing. So is it one of like that, or is it an independent, where it would be a two-sample test? So we're going to check for are groups related. Paired would be another way of saying it. So we want to show that they are paired. If we're using this test, we need to show they are paired and why. And you'll see that when we do an example of how you will write that out. Okay. So those should be familiar to you, except for the last one. And we kind of went over that yesterday. So for do the math, our general form for a confidence interval is just our point estimate and plus or minus, since we're doing a t interval, it'll be the t critical value times the standard deviation, which is s over square root of n. So that's kind of our general form for any kind of t interval. Since we're talking about a paired t interval, it's going to actually look like the x bar, or the mean, for the differences, plus or minus the t critical value for our degrees of freedom for this data set, and then our standard deviation of the differences over n, or the square root of n. So we're looking at the differences, the mean of the differences, and standard deviation of the differences. If you are doing these on the calculator, which is what we're going to be looking at in our example, you're going to calculate L3 by doing L1 minus L2. So you're going to enter your data here into L1 and L2. You'll subtract those to find the differences, and they will all be listed in L3. Then you will just go to T interval, and then your data is in L3. So this, when you're actually calculating it, you're just doing a one sample T interval. You're using that same option that we selected for our one sample test, because we're only concerned with the differences. You want to make sure that you're telling it to look in all three. And this part over here is just showing you, writing your conclusion is exactly what we've been looking at before. Nothing changed here. We are 95% confident that the interval from -3 to +2 contains the true mean difference in whatever. So all of that's the same. We just get the context right from the question, You'll be able to see that whenever we do our example. So, when we're looking at an interval, what does the value of 0 tell us? If it's included or if it's not included? What does that tell us about our true mean difference? Okay. Exactly. Now, we're going to fit kind of a lot in here, so write small. Don't start by writing little or big. If the interval contains 0, there is not evidence of a statistical difference in the samples. Because it's plausible. Remember that confidence interval is all the plausible values of the true difference. So if 0 is a plausible value of the true difference, that means there is no difference. So what if the confidence interval is negative? If the entire interval is negative, what does that tell us? Yeah, if we look at our order of subtraction, if we are always getting a negative value, then which one of these had to be larger? L2. Okay? So there is evidence here. Group 2 was larger than group 1. And if the CI is positive, then we would have evidence of the other, of the opposite being true. That was a lot to squeeze in there. So hopefully this is making sense. We've talked about this before a little bit, but now we're looking at differences and how the difference would actually work out as far as which one's bigger. So it all goes back to your order of subtraction. So you want to make sure you define which way you are subtracting. Okay. So let's look at the inside of our example. So here, this example is based on Mrs. Temple from across the hall. She enjoys reading during her summer breaks, and she was curious, does she get a better deal buying her books on the Kindle or buying them in paperback form at the store? So she found a random sample of 11 popular novels, and she compared the price at each location, buying it as a paperback and buying it from on a Kindle. So here are the prices that she came up with. So we want to do a paired procedure. Why would this be paired? Yeah, it's the same book that's being bought at both. So these are values for the exact same title of the book. These for two are the same book, just two different forms, Kindle and paperback. So that's why we're doing paired. So when we write out our procedure, we're going to be doing a paired t-interval And we need to define our order of subtraction so that we can carry that throughout the problem. So I'm just going to say mu k minus p for Kindle minus paperback. So I'm just going to do it in that order. So this is the true mean of the differences in price. And I'm going to define this as Kindle minus paperback. Typically, on the AP exam, if you use letters where it's obvious which one is which, they don't take off if you don't put this. But, you know, if there's any question about it, make sure you write this part. It's always safe to just write it all out. Okay, now we're going to check our conditions. So, first condition, we need random assignment or random selection. Did one of those happen? Yeah, she told us it's a random sample of 11 popular books. So, we have random. We know that because they told us that. Our second condition, we want to know about normality. So which of the three normality options are we going to use here? We're going to graph it because they gave us data. So for normality, so we're going to put, we'll say this is L1, this is L2. So we're just going to put these values into the calculator, the Kindle price in L1, the paperback price in L2. So go ahead and enter those into your calculator. Okay, so once we have entered that, I'm really concerned with the differences. So I'm going to go over here to L3. Oops. So over to L3 and then up to the top. So I'm highlighting where it says L3. And I'm going to do second 1 for L1 minus L2, second 2. And then when you hit enter, it's going to fill in that column for you. So those are all the differences in price. That's the column that I'm going to be using to do my test, or my interval. Are we good up to here? So then when I check my normality, I'm going to go second y equals to get into my plot. So for that first stat plot, I want it turned on. I want to select the last plot for my normality plot. And I want to use L3 where my differences were located. Okay. Once you have that entered, just do zoom 9, and it should come up to your graph. So there's what I have for normality plot. So it's reasonably linear. Okay, so I'm going to sketch this on my paper, and I'm going to write out a description of what I see. Sketched the plot, and then I made a statement about what I was looking for and what I found. So I did a normality plot of the price differences, and then I see that it's approximately linear, which is what I wanted to happen. And then my last condition that you have to remember to do now, this is paired because it was the same book spot from both places. So paired data due to same books being compared in price. Now, for our do the math, we're going to go back to stat and then to test. And we're just using that L3 column. So it's really a one sample. So we're just doing number 8, T interval. That's what you're going to select on your calculator, just T interval. And I'm using data. My list is L3, so you want to make sure you're using L3 for the differences. Frequency should be 1, and then our confidence level, they want us to do 95%, so we're going to leave that as 0.95, and then just calculate. So there's my interval. Okay. So all of this information I'm going to write on my paper. Then when we go to write out our conditions, we're going to do just like we did before. I go back up to the question, and I see this is my context right here. It's the true mean difference in price of Kindle and paperback books. That's exactly what I'm going to use to write out my conclusion. So I'm going to say we are 95% confident that the interval and since this is talking about money, I'm going to put $1.90 to 76 cents. And then from here, the true on, I'm just copying that sentence that we underlined up above. So the true mean difference in the price of Kindle books and paperback books. All of that just gets copied down here. So the process should seem very familiar to what we've been doing. It's just slight differences in the wording, but that wording you can get right from the way the question was asked. So it's very similar to what we did with just a one sample for means. Okay, so here at the bottom they ask us a couple of other questions that you may see come up. What would happen to our interval if we had a 90% interval instead of the 95% interval? How would it be different? Would it be smaller or wider? Or wider or more narrow? One of you, sir. Does anybody else have an opinion? Narrow. Good. As it gets wider, we're more confident. As it gets narrower, we're less confident because we have less margin of error, less amount we could miss by. So, based on our interval, does there appear to be a difference in the price of a Kindle versus paperback? Why? There we go. Since 0 is contained, it's possible there is no difference. So, since it contains 0, we do not have evidence of a price difference. So just get the form that you want. It doesn't seem to make a difference in price. Yep.
Going back to step 3, whenever you put in your calculator and did T interval, did you change it to L3?
Yes. Okay. This part, your turn, I'm going to leave this for you guys to do tonight because I want to get to the notes for the T test. So this, you will finish up on your own. So if you haven't attached it, that's going to go, those notes will be on page 97. Then take out your paired T test notes. We're going to go through this one. Okay, so again, we're looking for quantitative data. We want to look for paired or dependent samples, so if you've checked and you have those things, is what describes what you're dealing with, then you're doing a paired t-test. Your degrees of freedom, again, is n-1. Now we need to write hypotheses. This is what we were doing yesterday, so you should be somewhat familiar with it. When you're writing these, our HO is going to be that the mean of the differences is 0. HA is going to be the mean of the differences is not 0 in some way. So less than, greater than, or not equal to 0. Now, before we move on, I want to tell you, I give you these statements like this is always equal 0, this is always not equal 0. Almost always this is true. According to everything in the scope of this course, this is true. However, you need to start thinking about question 6. Question 6 is what they call an investigative task. That just means they will give you something that we have not covered. It'll be things that we've covered how to do it, but they're going to ask you a question in a way that is non-traditional. So they may say, can you show the difference in these two groups is, let's say we're doing a before and after, we're doing a pre-test, post-test. Can you show that the average gain on this test is at least 10 points? Then, instead of 0, you would have 10. So just realize, on most questions, 1 through 5 on the AP exam, the free response is going to be like this. But there could be that question 6, where they do something different. So that's come up before, things like that. So just be aware, it could happen. Just do everything the same. It's just that number will not be 0. Okay? So don't be worried about it. Just realize it could be different on question 6. And then you would define that mu sub 1 minus 2 is the true mean difference in whatever our context is. Just put in your context from the question the way it was asked. Then our conditions are exactly what they were on the interval that we just did. So it's either randomly selected, I cannot write today, or assigned. So either the sample was randomly selected or the treatments were randomly assigned. And for their normality, one of these 3 things will happen. Data is given, and then you graph it. And I'm going to say check for linear because usually we use a normality plot. So I'm going to say check for linear. And then our second option is if we have a sample size greater than 30, then CLC applies. And if neither one of those happened, hopefully it was stated to be normal. Then our last one, our third one, kind of our new one, groups are paired or dependent. And this is just whatever you would choose to use as the wording, just one of those 2 words, because whatever the reason is for that. Our test statistic, this comes straight from how you did z-scores since first semester. It's just the value that we're given, so the value from our sample minus what we thought would happen, our hypothesized value over standard deviation. So for this, our t is going to be, the value from the sample is going to be the mean of the differences minus what was the mean in our hypothesis over our standard deviation, which is s over square root of n, but here it's going to be standard deviation of the differences over square root of n. So we're just doing all of this for the differences between the two groups. On the calculator, just like we did t interval, like a one sample test, we do the same thing here. We just do a t test. You go write down what you enter. And then write down results. Make sure you include what is the value of t and what is the p-value. Still have a few people leaving out one of those two. So make sure you're including all of that. Then steps 5 and 6 are exactly what we've been doing. So I wasn't going to have you write those out again because you know these things. So you're either going to reject or not reject based on p-value. And then there is evidence or there is not evidence based on whether you reject it. You guys should be good with that. Okay, on the inside, let's look at an example. So here, we're skipping the video because all it is showing you these people shopping inside a store. So you've seen this before. I think you've all been inside a Walmart or a Target. So what we're going to do is we're going to enter Walmart prices in L1, Target in L2. And then we're going to create an L3, which is L1 minus L2. So go ahead and do your calculator part. We're going to do a paired t-test. And our hypothesis, I'm going to do W minus T for Walmart minus Target since that's how we subtracted for L3 equals 0. And then HA, we go back up and we look at our problem. We want to know, is there a difference in prices? So what inequality do I use here? Not equal. Good. And I'm going to define my parameter, mu W minus T. It's the true mean difference. We're doing Walmart minus Target. For for our conditions, first condition, randomization. Did they say anything about randomization in the problem? No. So we're going to put not stated, proceed with caution. So we don't say we can't do it. We're going to go ahead and do this, but we're going to recognize that we may have a problem here. We don't want to think that they took a sales paper for one of these two stores and picked items from that and then compared it to regular prices at the other store. Hopefully that did not happen. We're going to say, hopefully it was random. Then we're going to check for normality. So we're going to do graphing the data. So your calculator should already be set up because you just did L3 normality plot. So you should just be able to do zoom 9. And it should come up to your new normality plot, which, again, reasonably linear. And then we said this is paired because what? Yeah, we're comparing the price of the same products. Good. Checked all three conditions, we're good to go there. And if we do the math, we're going to go back to the calculator, stat test, and we're just going to do t-test, number 2. So we're using data. Our hypothesized difference is 0. We're going to use L3 for our list, frequency 1, and we said not equal to is our HA. So then we just calculate. And then I'm just going to record the numbers that it gave me. So the T is 791, p-value. There's all the numbers that my calculator provided for me. So I need to make a decision. So I'm going to compare my p-value 120 to my alpha level, which they didn't give me, so I use what? Right, 0.05. Good. So my p-value is greater than 0.05. So do I reject or not? Not. Good. And make sure you write what you're rejecting. Some of you are just saying reject, but you're not saying reject HO. That needs to be in there as well. So if we do not reject, we do not have evidence. And then we're looking at this statement that was written up here, a statistical difference in the price. That's what we're going to write down here. Okay, so you have your two on your own problems from your notes, your turn on each one of these, and then you have your problem set. So those and the practice quiz is posted online, so that should give you plenty of practice for tomorrow's quiz. So remember, it's the same thing as the one sample T. You just have to find differences and then do that. And I'll be posting my solutions to those that you're working on your own, so you can make sure you got those before tomorrow as well.